The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Trends in Industry Adoption of Big Data. And our guest speaker today is Ganeshan Pondurangan, Principal Technology Architect at Infosys. Ganeshan has been extensively working on creating big data platforms using Hadoop and NoSQL solutions. He has implemented large-scale solutions for Infosys clients using these technologies. So without further delay, I introduce you all to our guest speaker. Over to you, Ganeshan.
Yeah, thank you, Anuradha. Thank you very much. And good afternoon, ladies and gentlemen. First of all, I thank you very much for your time, that too on a holiday weekend. So, as Anuradha told, I am a principal architect with Infosys, and I have around 18 years of experience. And I've been working with these big data technologies for the last 4 years, and I've implemented these solutions for marquee clients of Infosys, and I'm leading this practice from India. Okay, I hope everyone is listening. So today what I'm going to talk, I'm going to have it as a 45-minute session followed by 15 minutes for questions. So today I'm going to talk about what is big data and what is the state of analytical systems and real-time OLTP systems in the industry today, and how our clients are implementing big data technologies. And I want to quickly look at the challenges of implementing these technologies, and want to quickly run through what Infosys is doing in this space. Okay, so that is what it is. So this is the agenda. I will give a minute for you to have a look at it, and I will transition to the next slide. Okay, so let me get into intro to big data. I think most of us might have heard what is big data, but just to give completeness, most of us relate big data to volume, variety, and velocity. So volume is a lot of data that is in terabytes and petabytes of data, and variety is, I mean, we want to put everything which contains no format or various format into one table or one data source or one source where you can start analyzing the entire data. Okay, and velocity is the speed in which these data or these information is coming into the system. We need to handle the speed. So with all these three things, right, I mean, we call the technologies that handle these three V's is what we call as big data. Okay, and most of our clients at this point of time, right, are using it to do analytics, big data analytics, and some of them are also doing to replace their entire what to call the old data warehousing systems and all those things. We will look into it further into the presentation, but I wanted to show you this in the left-hand side portion, right? I mean, what constitutes big data? I mean, from the various industry. This is a slide, or this is the information that I have taken it from McKinsey Global Institute. They have done a survey of big data, and they have understood, or they have come out with a report that many of these industries like banking, insurance, all of them have a large penetration of unstructured data. I mean, that is what this heat map is showing here. Okay, and what is happening is most of this unstructured data is not mined today to serve their customers. Okay, so that is their finding, and this report is around 2011-12 kind time frame. Okay, and if you look at this right-hand corner, 1 minute, let me just move this part. Yeah, right-hand corner, you see that the most of this big data being used by the information companies like Google's and Yahoo's and all those things. And if you also look at the observe little closely, the middle part of it, right? I mean, the healthcare services, the financial services, and the insurance are the big candidates that are likely to adopt big data technologies for various reasons. I mean, because they have a lot of legacy systems, there are a lot of data, and they are into the business of optimizing things post this 2008 what to call downturn. Okay, so what we see in the industry is leave alone this Google's, Facebook's, and those kind of industries. I mean, at least from the enterprise companies like let's say Apple or BofA, Bank of America, or any other companies like ICICI Bank or any other companies, right? I mean, those are also adopting big data. And I will also talk about how they are adopting big data. But let me transition to the next slide. Okay, so what we see as we speak to multiple clients, at least we are working with 50, 60 clients, and we see that 80% of their data is unstructured data. Okay, and only 20% of which is being used for their analytical purpose and real-time dashboarding and all those things. So if you look at it, right, majority of data is untapped. Majority of data is untapped, and they do not know what is happening in this unstructured data. I mean, I will just give you a simple example. For example, let's say I and the company X get into a contract, and I am always saying that, okay, if I have a milestone at some point of time, let's say after 2 months, and if I have to deliver some amount of work, right? I mean, there is no way that the contract document can be correlated with my output. So these are the problems that are really industry is facing. For example, this is one of the problems that mining guys are facing. For example, right? I mean, if I get into a contract and if my output has to be so and so tons of, let's say, bauxite, I mean, there is no way to measure against a contract unless a manual guy comes and measures it. So today that is the challenge that we are having in the this one, unstructured data. So this big data technologies gives us a hope to mine these kind of unstructured data, blend it with the structured data, and try to provide real-time analytics. Okay, so let me transition to the next slide. Okay, so this is a nice visual that I have put together. You can see that. I mean, just this one, right? I mean, the left-hand side, I'm showing a very structured information that is contributing to the analytics. Okay, and these are the reactive type of analytics, what people would have done. Okay, what has gone wrong in my system, or who is performing well, what is doing well, those kind of things, right? And this, the middle part is what I am showing as a little bit of unstructuredness is there. I mean, that is for purpose. I mean, if you look at it, right, my data is, I do not know what the data is, but it is large unstructured data, very complex data, but I want to bring it into my mainstream analytics and provide value for this. Okay, so these new things, right, I mean, these things need a different mindset, and that is what this machine learning techniques help us to do. And there is a new breed of people that are coming up called data scientists. We will talk about it a little later, but this is the state in which the analytical practice is evolving right now. So there is a backroom analytics that is going on. There is a real-time analytics that that we wanted to do, and most of the information is hidden in the unstructured part of the unstructured data. Okay. So the evolution is we want to embed this unstructuredness and the traditional structured data into the analytical process, provide insights which are meaningful, and they can take action or institutionalize that this one. Okay, so that is what we are that is what we are seeing in most of our clients. Okay, let me go to the next slide. So if you look at it, right, I mean, people can ask, hey, this analytic practice has been there for a while, I mean for almost centuries together, but what is so different? I mean, we have started optimizing the math behind the analytics, and today's problem, or what we call is long tail problems, in the sense that we are trying to find needle in a haystack sometimes. I mean, the population is very large, and sometimes what happens is that the probability of making a sampling error is very high, and you might lose out the real meaning by doing that sampling. These kind of technologies, right, this big data technologies, allows you to take a large set of data and go and do a deep dive analytics into it. Okay, so one example that I'm showing here is, sorry, it has gone. One example that I'm showing here is how the risk of underwriting goes with the various inclusion of various set of data. Okay, so if I start including various diverse information, my risk of underwriting my insurance goes down. So I'm just giving you an example, and this is what we have shown it to one of our insurance clients. The more and more you start incorporating various data, you can try to reduce the risk in your business. Okay, so I wanted to just take a minute or two to compare the traditional analytics versus the new approach that we see that the industry is going towards. Okay, so in the old this one, right, I mean, people come back and say that we need a business domain guy who comes back and says that, hey, can you find out what is going on? Can you tell me what has happened in the last 3 months? Those kind of analysis is what normally happens. And what people normally do is they go and get data from various sources. They have a what to call somehow they need to integrate the data, and data integration has got various problems like schema matching. We do not know which column to match where, how to make a unique record. Those problems are still there, and they use these technologies like SAS, IBM, SPSS, and all those things, and they try to make hypothesis, and they test the hypothesis, and they go back and tell that, hey, whatever you have thought through is correct or wrong. Whereas in today's world, right, I mean, we have technologies to tell business domain guys, say that this seems to be happening, can you go and check in your business and find out, I can also go and help them and say that why this is happening. So the trend is changing towards more proactive than reactive. And the technologies, I mean, it is not just a couple of variables. We are talking about more than tens and tens of variables that affect the business. Okay, so that is the shift that we are seeing in the analytical side. Okay, so this machine learning techniques is helping us to get to that scale and try to do predictive analytics. For example, right, I mean, we are discussing with a couple of customers where we want to tell them that a particular part of a mission can fail at this point of time and it might need a service. Okay, so those are the kind of things that we are doing. I mean, that is where the industry is moving towards. Okay, and let me just go to the next slide. It is transitioning right now. Yeah, it is almost there. Let me see. Okay, so the OLTP systems, right? I mean, how is it changing with big data? So, I mean, in the olden days, or even in many systems, even today, right? I mean, people work out of RDBMS and they work out of various other technologies like Java, J2EE, all those things. And I'm not saying it is bad, but the problem is there is a limit to many of these things. I mean, if you want to really benefit out of this unstructured data and all those things, right? I mean, it is not possible for Oracle database where, or let's say, I mean, an RDBMS kind of a database to have unstructuredness or to have to accommodate the various formats in the data. I mean, we have to make schema changes very often and all those things. So there is a new breed of technology that is coming up, which is a NoSQL kind of technologies where you can dump in any kind of format, and these are the databases have, I mean, the underlying technology that is underpinning these databases are distributed database techniques. Okay, so what happens is you can scale the system or scale the database as we increase as we go with the load. And there are a lot of concepts very similar to RDBMS, like sharding, replication, all those things. But those are all abstracted by the product nowadays, and you don't need to do anything with this. And the DBA activities are also coming down. So if you look at it, right, I mean, the OLTP system, many of the systems that I have seen, or many of that we are seeing, is it can scale up to a point of time, and beyond which your traditional systems are not able to scale, either because of you are not able to increase your cluster size, or your database is your single point of what to call choking point. So there are technologies which these big data technologies like NoSQL kind of databases like MongoDB or Cassandra or MarkLogic kind of databases, right? They give you distribution of their data. In Oracle world, or we call it as partitioning, but that is much more sleeker here, and they call it auto sharding here. And coming to the next part, right, the compute power, if I want to do a very complex calculation, in olden days people used to do it in one machine, one VM. Now we have techniques to do it across multiple machines. That is what we call as high performance computing, and Hadoop is one of them. Hadoop can be used one of them. Okay, so in nutshell, what we are seeing is most of these technologies are converging towards distributed systems, whether it is big data or NoSQL or whatever it is, right? The systems are getting converted to distributed systems, and many of these constructs like fault tolerance, replication, various distributed concepts have been already abstracted within these frameworks. Okay, so that is the crux of this particular slide that I wanted to talk about. Okay, let me transition to the next slide. So in effect, right, I mean, what we are seeing with the, what we are seeing in the entire industry is that many of our clients are adopting big data technologies for their real-time systems like MongoDB or Cassandra or HBase to scale their databases. Okay, and I mean, when I mean scale, we are looking at around, around 5,000 inserts per second with a large 1K, let's say 500 KB of data. So that is how we are doing. And many clients, as we have seen, right? I mean, they have gone up to even with this NoSQL databases, we have gone up to even 10 shards where we are holding around 500, 600 gigabytes of data. That is one of the trends that we are seeing in the industry right now. People are moving to NoSQL, and there is a new breed of technology called NewSQL, where they do things which are almost similar to RDBMS, and they also give you ACID properties and all those things. Okay. The other part that we are seeing in the data warehousing system is that people are moving into Hadoop. People are moving into Hadoop because Hadoop is a distributed system, and my storage and processing costs for my data is very less, and people are offloading their what to call the creation of aggregates and all those things into Hadoop. Okay, and to give you a comparison, right? I mean, I would say the storage cost would be much maybe in the tunes of 100 times less than a typical commercial data warehousing system. Okay, so that is one thing that we are seeing. I will go deeper into that augmented data warehouse solution. And the other thing that we are seeing is people are working with big data technologies to give you next best action, customer-centric personalization. Like for example, you go into any retail site right now. I mean, people might have seen this in Amazon, but Amazon is a very large-scale company. But the same thing is being now adapted into very small companies also. So we give you the next recommended items, and this concept is getting translated into industries, non-retail industries also. For example, you log into a financial website and you go and browse some of the products. The next time you get into a call center, right? I mean, the call center guys are equipped with facts that you are looking into these kind of products, and they will be able to do a recommendation for you. Okay, so that is kind of, there is a lot of work going on around that customer-centric personalization. Okay, and the third or the fourth bucket that we are seeing is the predictive analytics, where we are able to prevent or predict a failure of a part, or try to do a maintenance before the parts fail. I mean, we have done this for multiple clients, and let me be honest also here. I mean, the prediction is always, I mean, we will be more than happy if the prediction is around 50% accurate. So that is where we are right now, actually. Okay, and one thing that I forgot to tell was this social media analytics. I mean, that is, I would say there is a lot of hype around it, and there are a lot of challenges also. I mean, just to provoke some thought and do some more exploration, right? I mean, people are looking at their Facebook sites, websites, and trying to understand what is going on with the brand, and trying to correlate it with a customer or with their CRM system, and there is a lot going on there. I mean, someone has to understand the sentiment. I mean, the language by itself is a problem because the chat language is not same as English, and there is a lot of research going on how to understand this chat language, and there are dictionaries. There are dictionaries that can do this chat. You can put in the chat language, syntax and semantics and all those things, and people are doing. And if you look at it, right, I would say as long as your sentiment is 70 to 80% accurate, I think we have a fair chance of getting something useful out of it. So this is how we see, I mean, these are the 4 or 5 areas where our clients are using big data in a variety of things, either it be a real-time, whether it be in data warehousing or an analytical system or a predictive system. Okay, so let me take a small pause and understand and see if there are any questions that have come here. So far, no questions. So I'll just move on. Okay, so let me transition to next slide, please. Okay, so I'm going to get a little deeper, maybe not at a programming level or anything like that, at least at a design level, what we call as augmented data warehouse solution, what our clients are seeing actually. Okay, the pattern here is, I mean, people are moving their current data warehousing systems into Hadoop. I think users or the listeners are comfortable with what Hadoop is. Hadoop is a distributed system which has got a distributed file system, which has got a MapReduce framework, and which has got an SQL kind of a framework called Hive. And there are a lot of ingestion techniques also, like Pig, Oozy, and so many things, which I'm not going to talk about it today. But just to understand Hadoop for this discussion, right? HDFS, Hive, and HBase is enough. Hive is an data warehousing kind of a construct on top of Hadoop, and HBase is a database kind of a construct on top of Hadoop. Okay, just for people who have not heard about Hadoop, right? Hadoop is more of a file system based system where it is there is nothing called an update or anything like that. It is just like, I mean, there is no notion of something like, okay, I go and update a particular transaction or anything like that. So they have something called as MVCC, multi-version control, this one, concurrency and controls. So HBase can take an insert, can do an update, but it will create a new record, whereas Hive, there is no concept of update. So I'm just going to getting a little deeper, but at this point of time, right, what is happening is people are moving their workloads into whatever they are trying to do into their current systems, data warehousing systems and reporting systems into Hadoop. They create the aggregates, for example, right? I mean, I want to understand what has happened for my sales in the last 3 months or 4 months or whatever that period. Okay, so I have to aggregate data from various sources, and let's say I have various vendors, and these vendors I need to aggregate data. So what happens is people start pushing data into this Hadoop system, and they use a framework kind of in Hive, where they do a very similar SQL kind of joins on top of Hive, okay, on top of HDFS, and they create the aggregates, and the aggregates are getting created by MapReduce framework. Okay, so I mean, MapReduce is nothing but a scatter and gather kind of a technique where you run the aggregates across multiple machines and get the final records. So in a way, you can call it as a data reduction technique. For example, if you give 100 records and you want to find out the average, it will be one record. So these kind of data reductions are happening in Hadoop, and the process data is getting cataloged in Hive Data Mart. And there are, at this point of time, right, there are technology limitations which people are anyways working on. That is, you can't do a real-time query on top of Hive or Hadoop at this point of time. I mean, there are tools like Impala and Stinger and Drill and Google's and Yahoo's have already created. But when it comes to market, right, I mean, it is almost 5 or 6 years after they have successfully implemented it. So today, I think we are left with Impala to do a real-time query, but Hortonworks and MapR, those kind of companies are creating similar tools, and they're all open source tools like Drill and Stinger and all those things. So they aim at giving around 100x performance improvement on top of Hive. So you can run your real-time reporting and all those things from Hive itself. So if you look at this part, right, and the right-hand side of this, so what we are doing right now in most of the clients, right, most of the clients, people are moving data from HDFS into their current database, and they are getting the reports out of this current database. Maybe it is MicroStrategy or Tableau or ClickView or business objects or whatever it is. So this is the trend that we are seeing, and I will say that majority of the enterprise companies, whether it is in the gaming industry, like for example in gaming industry, people are doing weblog analytics, people are using this kind of infrastructure, and even in telecom industries, like what we call as CDR data, right? People are trying to plow through the call data records and understand how people are doing their call minutes and all those things. And even in the financial sector, right? I mean, we are using these kind of aggregate creation with Hadoop. Many of our clients are doing this. So this, we believe, that is a very powerful way of adopting Hadoop in an enterprise, this one, leave alone this Google's and Yahoo's, but this we believe is very powerful way of adapting Hadoop for normal enterprises. And this is going to drive innovation far ahead, and I will talk about the problems with this kind of setup and what innovations are going on at the later slides when I talk about the challenges. Okay, but this is one trend that we are seeing very heavily adopted, and we have seen clients getting at least 30 to 50%, if not 70% cost reduction when they move into these kind of solutions. I mean, because Hadoop runs out of local disk. Okay, so it doesn't need a sophisticated techniques like NFS and all those things. Okay, so let me move on to the next slide. Just one second, please. Okay, so this is another trend that we are seeing, right? I mean, a unified view of a customer. Suppose, I mean, I will give you a simple example. Suppose there is Colgate or Hindustan Lever, and you are trying to do some the HLL or surf, or somebody has got a page, and you are trying to put some comments about that particular product. So how is industry trying to take your feedback and try to improve that? So there are a lot of challenges here. I mean, they need to first understand your language, and they need to do some text natural language processing, what we call as text analytics. And there are tools that are available in the market. I mean, there are products also available in the market. But in Infosys, we use tools like Gate and OpenNLP and all those things. And what we do is we analyze that, we tokenize the comments that you put in Facebook and all those things, and then we clean it up and keep it in Hadoop. And on top of it, what we do is we go and look at their CRM systems and understand who is talking about this product, and we try to understand the influence. I mean, many times, right? Many times, me as an individual will not make much of a difference to surf, but at a corporate clients, I mean, if a dealer is talking about it, or if a mega contract guy, a guy who is having a contract is talking about a particular product, it makes large impact. So what we do next is we try to understand the influence of the customer, and then start creating a 360 of the customer, and say that this particular guy has liked this much, and he is about to transition, or he is about to churn from your offering to a different offering. So while I'm talking everything in terms of retail, right, I mean, these things are happening in the financial industries also, right? I mean, there are clients who are looking at money flow between multiple parties, and if something like a 2008 event were to happen, they want to understand how the money flow will be constrained. So there are a lot of models going around this, what to call 360 view of customers. So that is one area where where we are working with many clients, and this is where machine learning helps us, and that gives me a good segue into the next slide. Okay, so that is what predictive analytics is also all about. So let me tell you, right, there is nothing wrong with the incumbent approach, but the thing is the scale in which we are talking is very high. I mean, we are working at a graph database kind of a thing, I mean, where people are so highly networked, and we want to understand the relationship between the various people. So in a supply chain kind of a scenario, that is very important. Okay, and those approaches, the incumbent approaches, are very good when you are talking about variables that are, let's say, 10 variables, 20 variables. But once it goes beyond 100, or let's say 500 variables, I mean, even to understand how to visualize that kind of data is very difficult. And people do something like principal component analysis, and they try to reduce the dimensions, all those things. But in these kind of things, while those techniques are still valid, but we have a scale, we have distributed systems, we have distributed techniques that can do this computation across multiple nodes, and you can do this what to call algorithms in parallel. So this is where this Magot kind of techniques come into play. And most of some of the algorithms are parallelized, even in R, right? I mean, R is another analytical system where they are parallelized, and it is an open source system, and there are around 15,000 packages that people open source community is contributing to, and it is very robust and very versatile. And there are commercial packages that are available by many vendors, and they are also running in distributed mode actually. So here the analytics is very broader scope here, and it is much about trying to understand how things are, I mean, even before the business guys know it. I mean, that is what the predictive analytics is all about. And data scientist is a, what to call a unique form of profession that needs mathematics skills, that needs statistics skills, that needs computer skills, and that also needs very good algorithms skills and understand the domain. Okay, so this particular breed of people is in very high demand today, and the simple fact is that one person cannot have all these things. But as a group, right, I mean, there are a lot of courses around what is that, Coursera and all those things, which are helping people to get to that level at least. I mean, if somebody is interested, they can go and log into this Coursera and try and find what data science means, right? So they can look at it. So let me transition to the next slide. So I have spoken about all this analytics, real-time system, and all those things. So what is exactly the customer looking at? I mean, as I told you, right? I mean, there is 80% of unstructured data. So they want what to call systems that can enable them to discover what is there in this 80% of data, and they want to include all forms of data, be it let's say image, or be it audio, be it text or emails or call logs or whatnot. I mean, all forms of data they want it, and they want to do discovery on this data and do a correlation analysis between what has happened between multiple columns in this one. For example, right? I mean, one of the clients found that their video sales is very high when the weather is very what to call bad. That is, when the weather is snowing, their video CDs and movies renting is very high. So this kind of modeling can never happen in an relational kind of a thing, whereas you find that correlation with these kind of technologies. Like we do that correlation analysis within multiple variables and from various data sources. Okay, so that is one thing that people want to do it, and they want to do it by self-service. I mean, they want to do it by self-discovery. Though we say that they want to do it, right? Today's technology is not what, I mean, in my view, they are not auto-discovery. I mean, there is some help that is required from the programmers. They need to clean the data. They need to normalize the data. They need to do the data integration. Remember, data integration is one of the biggest challenge that we will have in bringing the data together. Okay, and that is what we are seeing in this one, that maximize the correlation. And people want, while they want to do all these things, the technology is very complex today, and they want to abstract the technology and reduce the time to insights. And they also want to operationalize the decision. I mean, there is nothing like, okay, I have found it, so what? I mean, they want to put this findings into the field, and they want to realize the money. I mean, they are spending a lot of money in doing this, but they want to realize the money that they are spending in this kind of initiatives. So big data, in my view, is going to help in in doing all these things. Okay, so as I spoke about all these technologies, right, I have a couple of minutes to talk about, I think I have 9 more minutes to talk about what are the challenges, what are we doing in Infosys and all those things. Before I get into what we are doing in Infosys and all those things, right, the challenges that I see here, right, I mean, you can't get everything in the world. I mean, what I mean by that is there is always engineering trade-offs that we need to do. And if, for example, in real-time systems, when we go for NoSQL kind of technologies, majority of them today do not do ACID. Okay, when I mean by ACID is atomicity, concurrency, integrity, and durability of the data, and many of them cannot get near here. But many of them also provide a single a single record atomicity, single record consistency, single record this one. But you want to operate on a bunch of records. The moment you do that, you cannot assure consistency. And many of them, right, I mean, though we say it is durable, there are occasions in which the data is not durable. And I mean, if people are interested, right, there is a theorem called CAP theorem, and it was developed in 2002 or around thereabouts of that. What it says is there are 3 variables. One is consistency, other is availability, and other is partition tolerance. So in a distributed system, you have to assume that the network will fail, and you need your products or your systems to be partition tolerant. Okay, when I mean partition, the systems get partitioned, the networks get partitioned. So definitely any product that we are going for should have partition tolerance. Whereas people are playing with the consistency and the availability part of it. So many of the vendors, for example, MongoDB is a strongly consistent database, whereas Cassandra is a highly available database. So it again goes back to your fundamentals of distributed systems and principles of distributed systems, whether it is a master and slave or peer-to-peer. So anybody that is requiring a consistency would go in what we call strong, a master-slave kind of a pattern, whereas people who are okay to tolerate the what we call consistency, where you are only dealing with a time-bound data, and maybe after 5 minutes or 2 minutes the data information becomes stale, they are okay to go with the availability part of this one. So Cassandra is one such thing. Okay, the real challenge in many of these things, right, while 95% of the use case can be accommodated with these databases, right, there are 5% border cases where you need to do unit of work and transactions. So there are a lot of mindshare happening, but it remains an industry, I mean, yet to be solved. But there are databases like MarkLogic and Aerospike who are calling as ACID compliant, but there are still border cases where you cannot do a distributed transaction and all those things. So this is a challenge that we need to work, and as programmers, as architects, I mean, we are finding ways to do this distributed transaction, trying to imitate a 3-phase commit and all those things. And in Infosys, we have developed frameworks to do all these things. Okay, so that is one part of the real-time databases. Again, the technology keeps changing, and there is a lot of things that needs to be learned in those world. I mean, it is not, I would say 50 to 60% of it is RDBMS, and rest of the concepts are new. So we need to do some unlearning there. Okay, so coming into the analytical systems, right? As I told you, Hive today, the entire thing is Hadoop as it is today is MapReduce workload only. But I mean, there is already Yarn, which is can accommodate any kind of workload, and I believe that in my personal opinion, right? I mean, that is the future thing. I mean, anybody who is willing to get into Hadoop world should know what Yarn is, okay, and what benefits it brings into, and should experiment that. And people are trying to solve this SQL on top of Hadoop using various products like Drill is from Mapr, Stringer from Hortonworks, and there are a lot of open source initiatives also there. So people are trying to solve. But still there are a lot of unsolved problems, like when we move into this augmented data warehousing solutions, right? Like when we are trying to move the workloads from this one. There is still not a notion of transaction yet. I mean, unless you go with HBase, there is everything is a file. Everything is a file, and everything is a partition in Hive. So you just can't do an update of a particular record. For example, I might have bought a song today from a site, let's say Apple site, and tomorrow I might have given it back, or I might not like it, and I would say there will be a grace period. I might give it back, or I might do an I might ask for a refund, maybe an X card, a gift card kind of a scenario. So what happens is I have to go and update certain records. In those cases, these kind of workloads cannot be, I mean, we cannot do that. But I mean, but we have done some workaround within Infosys. We have done some frameworks that can do updates and deletes and do compaction with the data as we grow with the data. As you have multiple versions of the record, right? I mean, you need to do compaction. So we are doing all these things. And what happens is sometimes Hadoop is too technical, too low level for business users. They want an abstraction on top of these hard technologies. So these are few challenges that we have seen, and to overcome some challenges, this is what we are doing in Infosys. I mean, we have got a product called Big Data Edge, where we are trying to do this, address the pain points that I spoke about. Like we are trying to do a discovery framework and aggregation framework that can do what to call a self-discovering platform and a usable platform where you bring in source data from various sources and create insights that normally would take months and months to take, but we have an automated drag and drop kind of solution which will help you to do a rapid visualization also. Okay, so this is one platform. People who are interested can go and look at Big Data Edge in YouTube, and it's a very successful product for us. And this is, I mean, some of the things that we have got there is we support both real-time as well as batch things. We have integrated with various leading open source products and search engines, and we have got our own data masking, data cleansing algorithms. We have got a lot of, we are fine-tuning some of the machine learning algorithms for pattern matching and all those time series analysis, and everything is enabled through a visualization that is coming default from the product. So that is what we are doing there, and we have got around 50 sources where we can pull data and 250 algorithms that are packaged nicely, and we have got 50 different ways to visualize data. Okay, so this is what we are doing, and my final slide is, 1 minute, next slide is, I mean, whatever I have spoken is about my experience at leading a group of 400 people, and we have done almost 20 plus engagements. I mean, the big guys of the industries, I mean, I would say the marquee clients, the biggest companies in the world, we have done work, and we have, I would say we have gone up to 600 nodes and handling around 1 petabyte of data for our customers, multiple customers, and we offer multiple services, all those things, and we have the largest Hadoop certified SI in India right now, and we work with Oracle also, by the way. So this is what I had got, and I'm left, I think I'm almost on time for 45 minutes. And by the way, we are also hiring. We are looking at good people who are willing to learn, or who have got solid experience in Hadoop and distributed systems. So that is what I had to say. I'm open for questions right now. I think it is almost 45 minutes now. Yeah. Thanks, Anuradha. I'm open for questions.
Yes, Ganeshan, thanks for the insightful presentation. Let's quickly take up the questions now. Please read out the queries and their answers so that all our users may listen to the insights. And you can find the questions in the question box. Are you able to access it?
Yep.
Yes. I request you to take them one by one. Just read aloud the questions and their answers.
Okay. Can it be used, I think Paresh Goswami, can it be used for automation data? Machine, 1 minute, I need to, let me see if, I did not understand the question. What can be used? Can it be used for automation data, machine unstructured data? Oh, okay. So if you are asking about what to call M2M kind of a solution, I mean, let's say we are talking about chillers, right? I mean, if you want to understand what is the temperature in which a particular chiller is working, I mean, for example, when, or even let me go a little in another way. Let's say if two routers are communicating and we want to understand what is happening within these two routers, we want to understand whether this router will work or not. I mean, these kind of technologies can be used to we need to tap the data and start putting into these technologies, and we can do the predictive analytics. Definitely, yes, unstructured data can be used for this one. I think that is what machine unstructured data. Definitely it can be done. But one way to do that is this unstructured data should be cleansed, or what to call, you should extract the information from that and then start doing analytics on top of it. I mean, someone has to do that NLP kind of a thing before you get into these technologies. Obviously, there are some what to call UDFs in Hive that can do that n-grams and all those things. But in my view, right, I mean, I would, unless it is a simple thing, I would cleanse the data beforehand and then move it into the this one. Hope that answers that question. How big data and data mining are related? Preeti Gupta. In my view, right, I mean, big data builds on top of data mining. Okay, so I mean, the very concept of clustering, classification, or what to call recommendation, all those things are part of data mining. Only thing is big data is at the large scale, and most of the algorithms that people have used are not parallelized, and hence if you look at R, right, I mean, they work out of in-memory. I mean, I'm talking about open source, this one, but people have come out with a very good this one, like R repay that can do parallelization, that can do a scatter and gather. I think they call it as DDS, or I don't remember that actual word, DDS or something like that, distribute and gather or something like that. So it is basically, in a simple words, right, it is a divide and conquer technique that people are trying to adopt, right? So those are the algorithms. I think in my view, data mining is the fundamental thing for big data analytics. Let me put this way, for big data analytics, and not necessarily for data pipelines and real-time systems, but for data analytics, data mining is the underlying thing. But data mining, big data is little much more than that, in a view that some of the concept, I believe, I mean, personally, I believe that, I mean, you can get away with these kind of sampling and all those things. But otherwise, I feel it is one of the what to call foundation of this one. Okay. Okay. Now there is another question, which is, what is the difference between Hadoop and Hive? What is the best for an commerce industry, e-commerce industry? Okay. So when you are looking at an e-commerce industry, right? I mean, people are using Hadoop, Hive, and all those things, but it depends. I mean, if it is an analytical system or a batch system, Hive is good enough, Hadoop is good enough. But if you are looking at a retail, an online system, you will have to go and look at databases like NoSQL databases or HBase kind of a databases. Okay, I hope that answers that question, but it's a very broad question. I mean, what is best for an e-commerce industry? I mean, it depends on the use case. I mean, even RDBMS is good for an e-commerce industry. Okay, now there is somebody is asking that means in future all data warehouse systems would convert into Hadoop. A very nice question. I think in my view, I believe if you are looking at a large scale data warehousing system, there is a value in going into Hadoop. There is definitely value in going into Hadoop, and there are cost saving benefits which I believe you can go up to 80 to 70% when the size of the data is in order of terabytes. Definitely, I believe that is the case. And interestingly, we are doing even from mainframe to Hadoop. We are moving a lot of workloads from mainframe to Hadoop. Okay. Okay. Now I got MSc Business Analytics in UK. I want to pursue career in big data. What are my? I would not comment on job prospects because I'm not an expert in job prospects. But I believe given an opportunity, learning is more important, and having a solid foundation is very important for the work that we are doing. And as I told, big data, I mean, data scientists, you need a multidisciplinary approach, and going back to university might help. I mean, but I would not comment on the job prospect and all those things. Okay. How do you see future of big data? Will it be able to help and use it for small scale industry? I definitely believe so. A lot of inventions that are happening that happened 10 years ago or 5 years ago in Google are now slowly getting adapted into a common banking or a financial or a manufacturing industry. And already we know that this NoSQL kind of databases, though it is distributed environment, though it can go up to, let's say, 100 nodes, and it can scale up to the Facebooks and all those things, there is nothing wrong that you can run it in your laptop also. So in real-time scenarios, I definitely feel that NoSQL databases can definitely give you the required benefit of cost. Okay. Okay. Any insights about big data in plant biotechnology and clinical industry? Definitely there is. People are talking about genome and all those things. We have one of my colleagues is a PhD in plant biology, who is in big data, systems biology, let me put it, systems biology, from postdoctorate from Caltech, and he is working on many of these things. I mean, if you want, you can connect with me later. I have given my email ID there in my front slide, Ganesan_Pandurangan@infosys.com. Okay, if Hive doesn't support real-time queries, can we integrate with other tools? Definitely yes, I've already spoken about that. I mean, it is not integrate. I mean, you need to export data to an RDBMS kind of a structure and then move data into that, and people do that. But I mean, it is within no time there are going to be tools that work directly out of Hive. Okay, so I'm running out of Hive. Still 7 more minutes, but I'm going to start culling the questions. Give me a minute or two. Okay, so how KPO industry correlate to big data? We are new to KPO industry. We are trying to find structured data and valid data. Okay, I mean, I do not know what it means, but in my view, right, I mean, as I told you, if your scale of data is very large, definitely big data will help you. I mean, that is what we are seeing in many clients. I mean, there is a value in moving your structured data processing also into Hadoop. I mean, people have done that. Okay. Data scientist, I've already shed light. I mean, I've already told the sources that are available. Okay. 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 In ETL world, wherein we deal movement of data from disparate system. Just want to understand how we scan metadata from Hadoop system in case we want to move. Okay. A very good problem actually. Pratik R. Okay. So right, I mean, the current offerings that many of the tools do not give today is data lineage and metadata management around big data. And that is where we in Infosys are focused on creating a platform that augments the capabilities of the tools that are available in market, which does the data cleanse, that what call data lineage and data governance and metadata management around this Hadoop system. And by the way, there is a tool called H catalog, which can handle metadata management in Hadoop. But I'm not sure that it will handle data lineages and all those things. But H catalog is a place where I would recommend you to look at. Okay, yarn is not going to override the current MapReduce. The current MapReduce is also supported. You can have a look at this one. Yarn will add more capabilities in terms of resource managers and all those things. Okay, so how can we implement any machine learning algorithm using Mahout? I mean, there are a lot of help. I think that cannot be answered in a small forum like this, or a small time frame like this, in a big forum rather. So there are a lot of tools, and I would recommend you download the Mahout package, and there are examples folder, and you can try playing around with the data sets, and you can try doing things. Okay, so skills, I think there are a lot of questions about how do you acquire this big data skills and all those things. There are a lot of universities. IBM has got big data universities, Cloudera has got Cloudera University, and Coursera has got a lot of courses. One can subscribe to it, and they can also download the SDK or HTTP or whatever that data platforms as a virtual machine, and they can try experimenting things. I mean, I would, as a practitioner, right? I mean, I'm also learning big data thing in the last 4 years, but I have still not learned the analytics side of it. But I would start getting, if you're new to big data, I would say start with Hadoop and Hive and Pig and all those kind of things. Okay, so I think most of the questions are related to how do I get skills and all those things, and that is what it is. I mean, one Lalu Kaktal has asked me, how can we tune any classification algorithm to get higher accuracy? I mean, it's a very broad question. I mean, you need to have the mastery in what the problem that you are trying to solve. You need to run it through multiple models and try to do that. I mean, I would rather post some materials in my blog somewhere rather than answering. It's not that easy to answer at this point of time. Okay, and some questions related test strategies for big data applications, right? I mean, that's very important thing. What I see is many people are struggling in this area actually. I mean, because that's very new, and there are frameworks. I mean, I would say that testing should happen in an SDK kind of an environment, and most of the distributed concepts, we know that the frameworks will work. So I would say start testing the data in a small scale, but beyond that, I think it is difficult to do a testing. And only thing is, you need to. There are things called. Someone also asked this question, right? There are things like precision and recall of the algorithm. So if you look at the terms, how much my algorithm is doing what it is supposed to do, how much algorithm is doing unwanted things. Okay, so we have to understand that precision and recall, and when you are testing these algorithms or anything, right? I mean, you need to ask the developer to tell me what is your precision, what is your recall, and show me whether it is at 0.8, or show me a graph between how these two things look for your data set. And the challenge here is data. I mean, the algorithm is good only for a certain set of data, and it may not be good for a different data. So you have to start understanding that part, and you need to start tuning that. Okay, I think I have answered most of the questions that have come in, and it is almost 5 o'clock, 1 minute to 5. So back to the organizer.
Thanks for the insightful presentation. Due to the time constraint, I will provide you all the unanswered questions which you can provide answers to offline, and I will share them with you through email. If you want to sum up today's session, you can do it right now.
Yeah. So the summary is that big data is going through its infancy, and a lot of what to call normal clients are also adapting. I definitely feel that it is a very exciting area that commoners like us, I mean, I'm saying that you will not be in Google or you will not be in this one, but the technology will reach us, and there is always there is a lot of openings as youngsters, right? If there are a lot of youngsters, as I've seen in the forum today, that there are more than a lot of programmers. I feel that trying to get to the basics of distributed system and looking at books like Andrew Tenenbaum, Foundations of Distributed Systems, I think they will get a handle on this Hadoop and all those things. I believe if you focus on the foundation, you can master the big data skills. I think that is the most asked question, so that's why I'm saying that. And definitely the technology will reach you. I mean, that is how I see it. Thanks, Aradhana.
I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Ganeshan, for all your time. Have a great evening ahead.
Thanks. Yeah, thanks. Thank you very much for your time, guys.
All right, I'll close the session for now. Bye-bye.